Hello viewers, welcome to our YouTube channel Incredible Maths. In this video, we will see some explanation about the definition of the group. So in the previous lecture, we saw the definition of the group and some examples. So here we will see some more examples. So before seeing the definition, before seeing the examples, so we will see a definition of the group in detail. So in the last class, we saw that the G, the non-empty set G, together with the binary operation star, is said to be a group if it satisfies some four axioms or conditions: the closure property, associative property, identity property, and inverse property. So that is, so the first one, A star B belongs to G for every A comma B in G. Second one, A star B star C will be equal to A star B star C. So this would be satisfied for every A, B, C in G. And third one, so for every A in G, there exists E in G such that A star E equal to E star A equal to A. And fourth one, for every A in G, there exists a unique B in G such that A star B equal to B star A equal to E. So here we call this E as identity element, and in this we call B as a inverse of A. So this property is called closure property. This is associative, identity, inverse. Now suppose if the operation star is plus, then so the definition or the condition to be satisfied is, so closure property, so the closure is for every A, B in G, A plus B should be in G, and associative, for every A, B, C in G, A plus B plus C equal to A plus B plus C. And identity, for every A in G, there exists E in G such that A plus E equal to E plus A equal to A. So here, so we can equate any two. So suppose if we equate first and last, so we get, that is A plus E equal to A. So here we will get 0. That is, if the operation is addition, usual addition, then the identity element is 0. So here we call this addition as usual addition. And inverse, so inverse property, for every A in G, there exists unique B in G such that A plus B equal to B plus A equal to E. So here our identity element is identity element, so E is 0, therefore A plus B equal to B plus A equal to 0. Therefore so when we equate the first and last, A plus B equal to 0, so B is equal to minus A. So what can we say about this B? B is the inverse of A. B is the inverse of A. Here suppose if the operation is addition, then we can say the inverse of A is minus A. So these are the important things. Then the operation is addition, usual addition. the identity element will be 0. This identity element we call as additive identity because the operation is addition. Therefore, this identity we call as additive identity. And the inverse of A will be minus A. So now we will see the case what happens if the operation is multiplication, usual multiplication. Suppose if star is multiplication, that is usual multiplication, then the closure will be for every A, B in G, A dot B should be in G, associative for every triple, that is A, B, C in G, we have star is dot here, A dot B dot C equal to A dot B dot C, and identity for every A in G, there exists E in G such that A into E equal to E into A equal to A. So when we get first and last, A into E equal to A, so this implies E is equal to 1. So this identity we call it as multiplicative identity. So because this is identity with respect to multiplication. So next, inverse for every A in G, there exists unique B in G such that A into B equal to B into A equal to E. So here E is the identity element and E is 1. A dot, so A dot B equal to B dot A equal to 1. So when we get first and last, A dot B equal to 1. So this implies what is B? B is equal to 1 by A. So what about B? So B is the multiplicative inverse of A. So that means, so here inverse of A is 1 by A. So the conclusion is this one. For the operation addition, usual addition, the identity element is 0 and the inverse of A is minus A. Inverse of an element is negative of that element. And when the operation is multiplication, the identity element will be 1 and the inverse of element is 1 by that element. So now we will see the example in detail. Suppose if we take z comma plus, that is set of integers under addition. So here suppose if we take any two integers and add, so we will get an integer, result will also be an integer, and that implies, so this will be belongs to z. So therefore it is for every A comma B in G, A plus B will be equal to some C, and C is an integer, so that means C belongs to Z. Therefore the closure property is satisfied, and the associative, that is if we can add three numbers in any order, that is for every A comma B in C, that is A plus B plus C will be equal to A plus B plus C. That is, first we can add A plus B and the result can be added with A. That will be equal to, that is we can add b plus c, and the result can be added with a. So both are same. That is, addition is immaterial. And the third property, so operation is addition, so therefore identity element is 0, so this belongs to Z. And the fourth one, inverse property, so inverse of A is minus A. Suppose if A equal to 1, then what is A inverse? That is minus A equal to minus 1, minus of A, so minus of 1 is minus 1. Okay. So similarly, so we can check when the operation is multiplication. So in the last video, so we have some questions, okay, so that we will take now. So that is, we have to check whether this Q set of rational numbers under the operation subtraction and real numbers under the operation subtraction is a group or not. Here and the question is, check whether Q comma minus is a group. That is, first we will take the closure property. For every a comma b in G, here G is Q, a minus b will be belongs to Q. Suppose if we take any two rational numbers and we apply this operation, that is, when we subtract the two elements, so the result will be a rational number, therefore that will be in Q. And second one, associative property. For every a comma b comma c in Q, so the condition to be satisfied here is, so instead of star, so we have to include subtraction, that is, replace star by minus. A minus b minus c will be equal to a minus b minus c. So now we will consider the left hand side. So left hand side is a minus b minus c, or we will do compute this one. So a minus b plus c, so this will be equal to a minus b minus c. So this is not true. Generally this is not true, therefore here associative property fails. So implies associative property fails. So therefore this Q comma minus is not a group. And similarly R comma minus, that is set of real numbers is not a group. So this you can check. Third problem you can consider is check whether Q comma dot is a group or not. So this you can take it and work out. So here this operation is usual multiplication. Okay. So we will end this video. So if you like the content of this video, kindly like and share with your friends. Also subscribe our channel. Thank you.